Let's take this form and run a second example. The last one took a little bit longer, so we'll obviously do this one in a second video. What can we change? Let's put an a value in here again, and let's also use a b value that's a fraction that's less than 1 instead, and we'll see what happens there. So let's graph y equals, I don't know, 2 times the sine of, let's do 1/3 x. Just for notation wise, you could also see this written as y equals 2 times the sine of x divided by 3, right? X divided by 3, this would be the same thing as x times 1/3. So the value there, right, that you're sort of multiplying by is 1/3, even if in some sense this looks like a division. So these two things are synonymous, right? You could sort of write this either of these two ways. You just want to be familiar with each and sort of make a plan, know what you need to do. Let's just run this down in order. So let's just sort of do our constants in order. So my a value here is 2. So my amplitude, absolute 2, which is 2. So I'm going to have maximum and minimum coordinates at plus minus 2. And then it's just going to be in my kind of usual pattern, right? Middle, max, middle, minimum, and then middle. It's not a negative in front, so it's not going to flip it. Probably was unnecessary to write all that, but hey, get some bonus words. So the new action here is dealing more with the b. If my b value is 1/3, so what the heck happens here? Well, so my cycle length, right, should be 2 pi divided by 1/3. Now if I divide by a fraction, I'm actually flipping and multiplying, right? So this is 2 pi times 3/1. Well, okay. So what the heck is that? That would be 6 pi. So my cycle length is 6 pi. So then that means my quarter cycle, so where my different points are going to fall. So 6 pi over 4. So my sort of quarter points, my distance between my points would be 3 pi over 2. This would be 1 1/2 pi. So let's just pause for a second. What conceptually just happened? So in the last one, right, when we were sort of multiplying everything by 4, 3? What did we multiply by? I should just check to be consistent. We multiplied. This is great. Oh, it's right here. We multiplied by 4. I remembered. So in the last one we did b is positive 4. We multiplied sort of all the x values by 4. So that means you're in some sense speeding up the cycle, right? You're sort of kind of multiplying the frequency by 4. It happens 4 times as often, and so the cycle length actually compresses down. What we're doing now is we're sort of slowing down the cycle. We're slowing the frequency. So if I do 1/3 times the x, it kind of slows down the rate that we're sort of going through the angles, which means now my cycle length, instead of being 2 pi, expands outwards. So it actually expands and gets sort of tripled in length. If I'm going to sort of slow down by a factor of 3, then the length of the cycle will sort of get multiplied by 3. We think about this and we say it in the right way, it kind of makes sense, right? So these points, what are we going to get? So starting at 0, x2 would be just 0 plus this, right? Cycle divided by 4. So that's 0 plus 3 pi over 2. So x2 just is 3 pi over 2. My third point is my halfway point. So that's 3 pi over 2 plus 3 pi over 2. That would be 6 pi over 2, which would be 3 pi. That makes sense, halfway between 0 and 6 pi, right? The fourth point, so 3 pi plus 3 pi over 2. This we said, right, was 6 over 2 plus 3, so that's going to be 9 pi over 2. That would be like 4 1/2 pi. Again, this makes sense. And then last but not least, right, 9 over 2 plus another 3 over 2. So 4 1/2 plus 1 1/2 is going to be 6 pi, right? Because this is 12 pi over 2 is 6 pi. So the table goes a little something like this. X, Y. So 0, our first x value, then write 3 pi over 2, so that's kind of our distance between these guys. 3 pi was in the middle, 9 over 2 was our kind of 3/4 point, and 6 pi was on the end. Our max min values, you can see them up here, right? Positive and negative 2. The middle is still at 0. So middle, middle, middle. There. This is my max, positive 2. And that's my minimum at negative 2. Let's make a sketch. You might ask, why am I not using graph paper? I think it's actually a little bit easier to freehand some of these graphs, just because, right, our like x and y axes are changing so much. Graph paper, I'm always really tempted to just sort of use 1, 2, 3, 4, 5, and so this way I can kind of play with it a little bit more if I need to. So our 3 pi here, 6 pi. Throw in our quarter points. 3 over 2, that was 9 over 2. Height, so down to negative 2, up to positive 2. Throw a couple extras on here, and graph away. So 0, 0, 3 pi over 2, up to positive 2, 3 pi down at the middle, down to the minimum, and then back up to the middle. If we want, we can keep going. That's going to be our pattern. So that was y equals 2 times the sine of 1/3 x. Again, Desmos is sort of a great tool. I believe it's just like a desmos.com, Desmos. It's a great graphing tool, especially because you can put some of these graphs on the same axis, right? We're sort of doing these one at a time. They would get pretty cluttered, at least as far as I would draw it, if we tried to sort of stack them up on top of each other. But if you did that, it would be a nice way to sort of really see the differences between these. We kind of end up drawing visually sort of just versions of the same curve over and over again, and we're really changing the labeling more than anything else. If you really want to sort of see different versions of the curve all stacked on top of each other, I would try Desmos. That's probably a good reference to use.